we go. There we go. All right. Variables and constants and working with expressions. And what we're doing with the expressions primarily is simplifying them, kind of putting as many things together as possible and evaluating them. If there's a variable in that expression and we're told a certain number to plug in for that variable, we evaluate the expression that way, and then we simplify it. Then as we get into more complicated expressions, we have rules for the order or hierarchy of the operations that we're working with. And I refer to it as GEMDAS, and some of you may have learned it as PEMDAS, where the P stands for parenthesis. I use G for grouping, a number of grouping symbols. And a couple things I emphasize, although it's written in that order, multiplication and division are the same level of hierarchy. Whichever one comes first, left to right, if they're just a string of them, and we'll look at that, a couple of those to start today, you just take them in order. Similarly, add and subtract are the same level of hierarchy. Just take them in order from left to right. Usually, well, just to make up something where that matters. Just here's our order of operations. And I've mixed division and multiplication and an addition operation. I kind of make the claim that a lot of times our eyes look at this addition in the middle and think that's an easy first thing to do. And then we think we're doing 20 divided by 10. But really, I have division and multiplication, and those are higher up the level here, hierarchy. So we have to do those operations first. This would actually be 20 divided by 4 plus 6 times 2. Do the multiplications and the divisions. They were two separate things, so I could do them at the same time, you might say. And now I can add those things together. So that's how, you might get tricked if you don't follow the order. Okay, slow me down or say, wait a minute. If you're trying to write things down, take a note, not if I go too fast, okay?
I have a question.
Yes.
Why is it 20 divided by 4? To me, it just looks like 20 minus 4.
I'm sorry, got to make my dots stronger.
Oh, okay.
Yep. Yep, exactly. Good. Good question, Bill. If it's not clear, please ask. Yes. All right, so here's one really talking about just the same level of hierarchy. I've got multiplication and division in the same problem or same expression. And what this rule is saying is I have to do them just in order left to right. So the first thing I want to do is 30 divided by 6, not 3 times 6. Okay, so the first thing I want to do is 30 divided by 6, and I get my 5. And now I'm still waiting to multiply by that 3 and get to the 15. A similar issue arises when you're dealing with a string of add or subtract at the same time. 9 minus 2 plus 3. You can't just say, oh, that's 5. 9 minus 5. You have to take them in order. 9 minus 2 is a 7. Then plus the 3 will get us to 10. What we're going to see today when we start working with negative numbers, kind of like that negative sign is attached to the 2. You can almost think of it as a negative 2, as a negative number when we start talking about that today. A positive 9, a positive 3, and a negative 2, we could actually kind of mix them around if we kept that negative sign with the 2. But that's what happens. You got to take them in order if you're just kind of doing it like an arithmetic problem. Okay. And a kind of example. Whoops. See if I can make something up here. And I'm going to make that a little bigger number here to work with. Make that a 9. Make that a 9. Again, I kind of call this kind of a trap. That is a minus sign right there. I've got 2, and here's a grouping bracket because inside there's some grouping parentheses. So I got 2 layers of grouping. So again, there's sort of a tendency to look at, you know, you got to do stuff inside first, and I guess we'll do that 1 plus 4 in a second. There is a tendency to say, oh, that's 9 minus 3 is a 6. That's actually 3 times whatever we end up with over here. That's a multiplication that's going to be a hierarchical higher up the list than this subtraction. We can't combine those right now. So when I see a problem like this, I just try to start with where I'm supposed to start and do one thing at a time. Like I'm going to do that addition right there. So I just rewrite everything else. And this is 3 times that 5 now. Notice I didn't need parentheses because it was just that number 5. I chose to use the multiplication dot. Let me know if that's confusing for any reason. Now it's kind of clear to see, oh, there's this multiplication we're supposed to do before the addition. Oh, I'm going to get myself a negative number. I hope you can live with that for right now. 9 minus 15. Kind of sets us up. I was trying to avoid that before I really talk about it, but gee, 9 minus 15 means I'm going in the hole, right? It's going to be a negative 6 in there. That's not quite sure about that. Don't worry about it just yet. But now 2 times negative 6, I get negative 12. That's what we're going to do a lot of today. But I wanted to just address that sort of trap right there. Don't try to combine those. That's actually a multiplication. Okay? If that's all right, I'm going to go on next topic. And really the last topic in 1.2, just covering everything, even though I know what most of you got through that material. We're combining like terms. When we have an expression with several pieces in it, each one of those pieces that are separated by pluses or minuses are called terms. The term contains numbers and constants and variables multiplied together usually. So here's a term that has 5 times x. Here's a term that's just the constant 3. Here's a term that's 4 times x, so multiplication, and the constant 7. So this expression has 4 terms. Now, the concept of like terms is looking at each of those terms and putting together or being prepared to combine all of those that have the same variables with the same exponents on them. And combining constants is just, yeah, combine the numbers. Like here, the 3 and the 7, those are going to be constants I'm going to combine. Here's a 5 times an x, and here's a minus 4 times an x. So they both have x as a variable, and we never bother to write it, but they have the same exponent 1 on them. So those 2 are also like terms. We can put all those x's together. How many x's do we have? So I can actually kind of jump around and say I have 5 x's minus 4 x's means I have 1 x left. We usually don't write the 1, but it's implied there. Here I have a 3 plus a 7, a positive 10 for the constant value. So there I combined the like terms in that expression. How might it get tricky? How about there I wrote, 1, 2, 3 different expressions. 2 of them are like terms. Which 2 can I put together? 1 and 2, 2 and 3, or 1 and 3?
Sorry.
The dog got it right. Now here I tried to trick you, right? There's x squares and 1 y, and here's only 1 x, but y squared. Those aren't the same. X squared and a y, it didn't matter about the multiplication order. Here's 1y and an x squared. So those 2 are actually like terms. you know, 2 times 3 is the same as 3 times 2. We'll talk about those rules later, but the order that you multiply in doesn't make a difference, doesn't change. So I could actually combine those two and say I have 7 of those things. So there's combining like terms. All right. That kind of wraps up the ideas in section 1.2. And here's a good time for you to jump in and ask a question or about evaluating or something like that if you have it. Okay.
Will we be able to use any notes we've taken on the test?
Not supposed to, okay? In fact, your first test question is usually, I agree not to use any outside help or sources or books. You get your calculator, you know, but you're at home taking your test, you know, it's honor system, but I'll be able to see your work on tests. You'll have to scan in. I was just about to talk about that. Your work for me, and if you're not showing work, I'll know. Excuse me. In fact, everything that we're doing right now in the first couple of chapters in the classroom setting, you would be required to do it without a calculator. Only till we get to things with like percents and decimals where we start allowing you to use a calculator. Well, you're at home, we really can't monitor that. So we're sort of assuming you're going to do a lot of your arithmetic with a calculator, okay? I did want to change gears for a second and talk about scanning. I'm going to do my screen share thing here and go into my open math for a second. And let's see, got to change. And so you should be looking at my open math page right now. And I'm going to scroll down, and in week 1, right, I talked about this yesterday. There's all the my open math. You can't see my finger. Use the cursor here. There's all the my open math homework sections, but way down at the bottom of that first week is hand in homework for week number 1. I think it's 5 or 6 problems. You're doing most of your work in my open math, but getting you used to writing on paper and showing work and then turning it into me. Now, let's see, I'm going to reset this. I'm going to show kind of what I see, teacher preview. But if you start, because I can just do that. Here's what it looks like. And if I click on that in a second, it would pull up the PDF. But what I want to show you is, let's see, the instructions. And then if I go to the next thing, here's the screen that you see when you are ready to upload your work to me. There are 5 different, some people have trouble getting their document into just one document. They need for some reason, you know, a picture for every page. So you can actually upload up to 5 different pages, but don't submit until you're finally done with getting all your pages in there. So from here, just like you might upload a file from your computer, you know, you choose a file and you go in your computer, wherever you have saved your scanned work. Well, where do you get that scanned work from, right? Well, if I mentioned yesterday, if you're lucky enough to have a printer at home, that a lot of them have scanning capabilities. I happen to have an Adobe account for some other stuff. So on my phone, I have the app Adobe Scan, and it makes a nice PDF quality picture of anything I scan with it. Here in the instructions, it mentions a couple of other free scanning programs. Cam Scanner, I went and looked at my phone yesterday. It kind of looked like a good one, or Genius Scan. They're supposed to both work, and it doesn't matter which one. But those are apps you can put on your phone, and it allows your phone to use its camera and kind of make a PDF quality picture. And then hopefully you're familiar with being able to download pictures from your phone to your computer, and or uploading directly from your phone. Again, if you're just trying to do this class on your phone, I think will get cumbersome or difficult at times. So I always encourage you to try to use your computer. So there was just a sort of a quick how to, you know, what do I use to scan? Go look at the App Store and enter scanner, actually, scanning apps, and it'll pull up a bunch of them from your App Store. Okay, that's kind of all I wanted to do with that right now. Any questions before I leave My Open Math?
Yes, Steve.
I'm listening.
Do you want our work that we've done for our homework to show our work?
Not for any of the My Open Math. Okay, so you do your work for My Open Math and you enter your answer and that's it. The hand-in homework is work that you do on paper, whether it's whether you print out that document that is in there. It's a worksheet. You can print that out and then scan it back in, or use your own paper. So only the hand-in homework do I need your work.
Okay, where is that? Where are those?
The hand-in homework?
Yeah.
Okay, that's just where I was. Here I am in week 1 still, all right? Week 1, at the bottom of week 1, there's hand-in homework for week 1. Every week has that, unfortunately, at the bottom of the week. So if I say reset for myself, if I start, here's what you would see, and there's this link to the hand-in homework. And here's what the first week's looks like. And you can print this out, or I suppose you could just do it on your own paper if you'd like. Let's see, what am I asking you? Evaluate, plug some numbers into that expression, kind of use order of operations to simplify it. Similarly, there's something different about number 1 and number 2, even though they look very similar. Number 3 will be related to what we talk about today. 4, again, simplifying, but starting to get into fractions, which we do at the end of this week. And similarly for 5. So 5 questions for you to work out on paper and scan in and send to me. So that's an example of hand-in homework.
Thank you.
Okay, so here I go. I'm going to stop that share. We're going to go back to, there we are, back on my whiteboard. All right, so I'm going to go to 1.3 now. And change my notes here a little. All right. We use a number line to represent relationships frequently. And right now, up until this point, we've been dealing with the whole numbers and so on, right? Dot, 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 they go on to infinity and beyond. Anyway, the whole number start at 0 and then use the natural or counting numbers from there on. Well, we all know that we sometimes overdraw. You can imagine a lot of this, the definitions of the number system came from commerce. Thousands of years ago. You know, how do we account for these things? Well, counting numbers were pretty natural to work with. What's the quantity? How many do you have? It was kind of a big deal when they invented none, 0. We need a placeholder. We need a symbol to represent none as we do our calculations. So that was an important addition to the mathematical system long time ago. Well, we know that we overdraw our bank accounts once in a while or something like that. And we have those numbers that go into the red. I'm going to keep using my black right here. We have the negatives or opposites, the opposites of the whole numbers here. We call them opposites. Whoops, that's now a 5, right? So those were the whole numbers, and when we add their opposites, we get the new set, the larger sets that's called integers. So this is a word I'll use a lot. We'd like to have all of our homework answers be integers and not fractions, messy numbers, if you're lucky, okay? But we now have an expanded set of numbers to work with, like that last example actually for PEMDAS that I made up with. The relative size. We say if anything moving in that direction is getting larger, more. You know, it's getting bigger if we're moving to the right, and it's getting smaller if we're moving to the left. So any number over here is less than any number over there. First few section 1.3 homework problems will ask you to use our inequality symbols just to define that relationship. 9 and -11, and there's a blank. Which one's bigger? Put the correct symbol in. 9 is over here, -11 is over here, so 9 is greater than -11. Even though that kind of looks like a larger size number, it's more negative than the positive, but positive is always more, a larger value, we say, than the negative. Just think about your bank account, right? Positive is always bigger than negative. So that kind of problem is kind of where we start in this section. And so from there, we kind of move to, do I want to do that other thing next? We do talk about their relative size. Well, this number 4 is 4 units from 0. It's a number, it's a quantity size 4. It happens to be in the positive direction. The number -4 is also 4 units from 0. It's a number that has sort of a size 4. It happens to be in the negative direction. So this concept of what's the distance from 0 or the size of those numbers is referred to as absolute value. And usually defined as distance from 0 without regard to direction. So -4 and 4 have the same size or absolute value. And that value is always expressed as a positive number. Now we need some symbols to describe what we're asking for, absolute value. So we use vertical bars next to around the number, around the expression. So when we see that, it's asking you, what is the absolute value of -4? How far from 0 is -4? And the answer is, well, lucky I can leave that there. It's always the positive number that is that distance. The absolute value is 4. What's the, well, the absolute value of +4 is also 4. The result of that operation will always be a positive number. The absolute value of -5. How far from 0 is -5? 5 units. It's a 5, positive. Okay, so we can compare. Now, so if I give you one of those problems, use one of our comparison symbols. The absolute value of -4, how does that compare in size to 4? Which one's bigger? Well, they're actually the same. That number simplifies to 4. 4 equals 4. So that's kind of playing games there with that symbol and our inequality. I guess I could do the absolute value of -3 and -2. Which one, think carefully, evaluate it. What is the absolute value of -3? How far out from 0 is -3? 3. Now you're just asking which one's bigger, 3 or -2? Duh, right? The 3 is bigger. Absolute value bars are a grouping symbol. Make myself a little more room. I think I'm done with the number line for a moment. It's a grouping symbol. I'm going to make this big number here. Now maybe I should have just left my number line for a second. If I start at 7, here I'm going to do this real quick here. If I start at 7 and I subtract 9, subtract 7, well, I got to get 2 more. I'm going to end up at -2. Kind of getting a little ahead of myself there. But the value, evaluating what's inside absolute value bars, like a parenthesis, like a grouping symbol. This is actually, what is the absolute value of -2? 7 minus 9 is -2. What is the absolute value? How far is that from 0? Is a 2 units, +2. So that's how we play with relative size, positive or negative. We call it absolute value. We compare them, kind of practice that way, and watch out for expressions inside. Do all that simplifying first. Okay. Going on. The whole numbers and their opposites. So the negative signs, we kind of have 3. Did I even have a list of 4? So 3 uses. Yeah. 3 uses for that minus sign. We're familiar with, we use it to subtract 2 whole numbers, 5 minus 3. Here it represents the operation subtraction. Opposite or negative number. This is indicating this is the number that is 2 units to the left of 0. -2. Okay. So it's saying the opposite of 2. Now this one's sort of a variation of that. This is saying the opposite of that number that is the opposite of 4. The opposite of the opposite. We're going to work with that. That ends up being positive. The opposite of a negative is a positive. Opposite, opposite. If you can just start now getting comfortable with the idea that the negative of a negative is the positive. That's probably one of the first places where people start getting confused. Negative, negatives. And then the kind of the last, so that was really related to that. The last use is when it's attached to a variable, it means the opposite of whatever that variable number happens to be. Is that variable a positive or a negative? Depends on what you put into it. So I might get, if x equals 2, then the negative x is -2. If x is -3, then this expression, the negative of that is the opposite of -3. Here's where I start spinning your head, right? Got to decide, got to plug in that. Notice I had to use sort of parentheses to wrap up that negative sign so I could put a negative outside of it. I have this is this negative, and then this is the opposite negative, and this is the -3 inside there. We tend not to put operation or number signs right next to each other. We don't do plus minus right without some parentheses. We wrap it up in parentheses. Okay, so it's kind of the different ways that we're going to use this negative sign and try to make some sense out of it. Another thing to point out, just one more idea related to our absolute value. Remember, the absolute value is a grouping symbol. Evaluate the absolute value first. This is saying I want the opposite of whatever that absolute value is. Absolute value is always a positive number. So this is saying I want the opposite of that positive number, and this will make it negative. Not because of anything inside, but the one on the outside is saying change the sign. So that's a 5. That makes this -5. Okay. Hope that works for you so far. Checking the notes here. Right. All right. Are you ready? Here we go. let's do some adding and subtracting with integers, which means some negative numbers also. So I've got another class you can go to if this one's too tough. Haha, that was me. Here we're just subtracting two positive numbers. I'm going to sort of point out, we assume these have a plus sign in front of them and we don't bother to write that. Okay. How about, but what if I say 5 plus a negative 3? Here I'm going to add these two integers. This is 5 units to the right. This is 3 units to the left. Adding the opposite is the same as subtraction. Mathematicians can get real abstract and say, there's really no such thing as subtracting. It's always adding opposites. So these two mean exactly the same thing. I started at 5 and I added 3 in the negative direction. I subtracted 3. Some of the homework, again in my open math, asks you to take this kind of problem and write it as the sum of signed plus minus, sum of signed numbers. So this is the same as adding a positive and a negative. So they want you to take this expression and rewrite it like that expression. And then next step might say, all right, now evaluate it. Like I did, and I came up with my answer there. Rewrite it as the sum of, as a sum means addition, sum, hopefully you're familiar with that, as the sum of signed numbers. Those numbers have a sign that goes with them. This one happens to be plus and that one happens to be minus. Okay, for example, how about negative 3 plus 7? This is very similar to that first one in a sense. I just happen to start at negative 3, right? Start at negative 3, and now I'm going to add 7. I'm going to move 7 in the positive direction. You know, 3 is 3 of them, and it takes 4 more, right? So I was 3 in the hole, and I got 7 more, and now I'm positive 4. All right. Now, that is written as the sum of signed numbers. We just never bother to put the plus sign on the positive number. Here I'm adding two signed numbers. They both happen to have the negative signs. This is saying I'm starting at negative 6 and I'm adding or going 3 more in the negative direction. Negative 6 and 3 more in the hole. Minus and more minus. Kind of the way I usually say it. Gets me to minus 9. Notice I might have seen that originally look like that. Negative 6 minus 3 more. Maybe that makes perfect sense to you. That same number. Again, if start getting jumbled up, drawing yourself a little number line like that and say, okay, I'm starting at this number, positive or negative, and did I move in a positive or a negative direction for the next one? All right, let's not make that so big. Now, in fact, I'm just gonna, sorry, erase that. Not to get quite that messy yet. Here I'm starting at 7. And I wanna subtract the opposite of 8. Take away the negative. Think about your bank account again. If you take away your debt, you're moving in the positive direction. Minus a minus is the same as addition. Minus minus, subtracting a negative is the same as adding. A lot of times folks have trouble absorbing that right away. If you can sort of keep an eye out for it and believe it if you have to, save yourself too much anxiety. But yes, we know that's 15, right? I started at 7 and I'm taking away -8. So really moving 8 more in the positive direction. Subtracting a negative. Yeah. Oh, well. Here's a similar one. I just happened to start from -5, 5 left of 0. But minus is this, subtracting a negative is the same as adding. Again, some of our MyOpen math classes will ask you to rewrite this as a sum of signed numbers. This is just like I did a second ago for the other one. This is the same as 5 plus a positive 9. Subtracting a negative is the same as adding a positive. Now, hopefully, looking at those two, I start at -5 and I add 9, I get to +4. Haven't said it yet. Hopefully it kind of has made sense. Anyway, if we're adding two numbers with the opposite sign, we actually find their difference. What's the difference of 9 and 5? And then apply the sign of the larger absolute value. 9 was a bigger size than 5. The plus was bigger than the minus. So this result was positive. If I have just to make one up again, here I'm starting at -7 and adding a 4. Opposite signs for this addition. So I'm really finding the difference between those two numbers, 7 and a 4. What's the difference? 7 minus 4. And it's a 3, but which one was the larger size or absolute value? It was more negative. So we're still in the negative side. We're still 3 on the negative side. And here again, a number line can help you if you know you started at -7 and I'm adding 4 in the positive direction, 1, 2, 3, 4. Oh, I got to -3. It kind of graphically works that way. All right, how are we doing? Translating. Translating an English phrase into an algebraic expression, setting us up for word problems eventually. Translate that English sentence into an algebraic expression. The sum of 9 and -16. Here's where you have to know those words that go with our sort of standard arithmetic operations. Sum is plus, difference for minus or subtraction. A product is multiply. So I need to write those out or get them to yourself here as we go. Sum, difference, the product, and the odd one, quotient, Q, right? Quotient is the word we use to describe a division problem. So here we're looking for the sum. So it's going to be an addition of those two values. So 9 plus, and since that is a negative signed number, I'm going to use parentheses to wrap that up. Please get into that habit. Kind of a two-parter here. Again, translating. the difference, yeah, write that right. Difference of 3 and 5, comma, I'll be good to you that way, increased by 7. That comma kind of implies this first phrase stands alone. The difference of 3 and 5, that's one part. How do I write the difference of 3 and 5? Difference is subtraction. There's the difference of 3 and 5. When we're talking about subtraction or division, you want to present those numbers in the order they were given. So it was 3 minus 5 and not 5 minus 3. The difference of the first and the minus the second. Now, increase that by 7. Well, okay, we can get away with it. Order of operations will tell us to do it correctly. We can increase that by 7 by just adding 7. I was going to suggest that you got to be careful. Sometimes, in order to make that work right, I can imagine a situation, I didn't think of it ahead of time, where we might want to put that in parentheses to really make sure that is done separately. But order of operations would tell us to do 3 minus 5 first, and then add the 7. But just writing an expression, I'd say either one of those would be fine in this case. And looking at homework sample problems. How tricky can we get, huh? Always checking my time here. Got a couple minutes, good. Oh, let's see. An order of operations problem. Many of your homework problems at this level will ask you to simplify this expression using the order of operations. Follow the rules to combine things as much as possible. Well, I do have a couple grouping symbols. And so I need to do the things inside the grouping symbols first. So 2 minus 7, negative 5. If that doesn't make sense to you, let me know. But don't really need it because the negative sign, it's the first number, but I'd still just put in parentheses around it because it's a negative number. And this minus we haven't done anything with. 3 minus 8. 3 minus 8 is negative 5, isn't it? This one I definitely need parentheses, and that gets multiplied by 2. If we haven't really multiplied these things yet, I think that's supposed to be the next chapter, but oh well, hopefully that's the next section. Hopefully this isn't too confusing. But now I'm really down to additions and subtractions, except for that one multiplication. I have to do that multiplication term right there first. 2 times negative 5 means negative 5 plus another negative 5, negative 10. Negative 5 minus negative 10. That just took care of 2 times 5, and it was a negative. Now, I have a subtraction of those two negative numbers. Negative, negative, subtracting a negative. Kind of the best, easiest thing, or I want to say safest thing for you right now is to just rewrite it with a plus sign. I left off the parentheses that time. This subtracting the negative turns into addition. Negative 5 plus 10, it's going to get me to positive 5. Jot that all down. I think I'm going to leave you with that. I think I did get this recorded well, and it'll be up on the website, in a couple hours. It takes time for, I think I'm going to send it to YouTube and post a YouTube video. It takes a while for it to upload there. But I think I got it, my presentation system ironed out today. So I can post a good video. So I like that many of you took my advice and just got started, gave it a try. Did 1.2 yesterday. That's really the best thing to do, is go start that section. Don't wait till Sunday night because it's due Monday. Just if you can get yourself into a good routine, good discipline, that's the best way to do it. And ask me questions, okay? Send me questions. Otherwise, unless there are questions, I'm going to end this meeting for today, okay? All right, folks. Have a good day, and I'll see you here tomorrow. Same thing, on to the next. All right.
Great day.
All right.
Thank you.
See you later. Bye.